Hello everyone, hope you are doing good and welcome back to my channel. Today we are at day 21 for the daily Leetcode challenge of January month and we have some very good questions in front of us. It's question 198, house robber. So according to me, this question, first of all, let's see the constraints. If you are a beginner, I will say that practice this kind of questions. I really felt happy while solving this kind of question. It does not require you much, knowledge of any data structure as such. It just based on how you are thinking and whether you know the ideas on how to answer solution. It's a very good question. If you are a beginner, definitely give it a try and then do watch my video to get a real idea of how to solve this kind of questions and what are the things involved here. Okay, so let me begin the question now. But if you want to solve it, give it a try now. You can pause the video and try at the same time. So coming to this question, see, as you can see, we are input. We are given an array called nums. Okay, what are these nums? Is actually this represents the money. Okay, money in each house. So we'll get to know that. But I just want to give you a heads up that input is only array and the output is going to be integer. Okay, let's see the question now. You are a professional robber. Okay, planning to rob houses along the street. Each house has a certain amount of money stashed. Okay, as you can see, these are the money stashed in each of the houses. Okay, the only constraint stopping you from robbing each of them is the adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into the same night. The idea here is any two adjacent house you cannot rob in the same night. Okay, that is idea here is you should not rob two houses at the same time. Okay, I mean in the same night. So idea here is once you say, let us say you chose this house, then you will have to forego the three and directly come to one. Okay. So the money in this case you will make is two plus one, which is three. Okay. The other option is maybe you can take one from here and then maybe here three. So when it will give you an answer of two. So that is the basic idea here. The idea is you should not be aiming to select two houses which are adjacent. Okay, that is the basic idea. Given an array nums representing the amount of money for each house, return the maximum amount of money you can rob tonight without alerting the police. So the idea is very clear. You should not be selecting adjacent elements, and then you will have to decide which way you should proceed in order to select that in order to get the maximum money without alerting the police. Okay. So, okay, like, I will give you some ideas here. Maybe like by those ideas, you may be in a position to code the solution. You can try that out. Listen to my ideas first, and then maybe you can pause the video and try it out yourself. Okay. So in this case, like let us discuss what are the various possibilities. Okay. See, first option is I can take one. Okay, I can take three. It's a very obvious option, right? Because they're not adjacent, as simple as that. And now in the case, if I start from two, okay, the only option which I will have is one. Okay. Uh, can you think of any other option? Yes, there are more options. If I select this one, try to understand this fact. I need not select adjacent one. Okay, so I should not be selecting two next. But other than two, I have every other option. That means I can select this one as well, this one and this one. Okay, that also forms an option. Okay, so there are many ways here. Okay, only the adjacent one I should not select. Rest all I can select. So try to understand this fact here. So yeah, that is the basic idea. Now, can you tell me one thing? Yeah, so that's what I'm trying to do. Now I will just quickly give you a scenario. In that you will have to tell me if that is possible or not. Let us say I have only one comma three. Okay, only two elements I have. Now what will be the solution in this case? Can you quickly tell me? You have to only array of two, and now if you tell me what should be the maximum money without alerting the police, obviously you will say the answer is going to be three. Okay, yeah, I agree. Now let me tell you that I will add just one more element. Again, the answer will be what, two plus three. Okay, that is there. Now, if I tell you that I will add a one here, now can you tell me the answer? Yeah, it is going to be two plus three. Okay, so the idea here is they need not. Okay, now tell me for this two comma one comma three. Obviously, the answer will be 2 plus 3, which is 5. Okay. I will forego these two elements. As simple as that. So, these are the various things we have to keep in mind while designing the solution. Okay. These are just some examples, and I've created some more test cases as well. I will show them while running the code. But try to understand the idea here, what is happening here. Okay. So, what I will do is I will try to maintain a cache array. Okay. But try to understand the concept involved here. Okay. See, it's same as that of the length of the given array nums. Okay. That is one point. Other point is it will be initial with zero. But try to understand what is this cache array. See, cache of I will be maximum amount of money robbers can collect if starting at index I. Okay, why this important? Okay, see, try to understand this fact here. See here, I am at one. Okay, suppose I am at one. Okay, now suppose I have the maximum money that I can collect by starting at this index, and I have the maximum money that I can collect from starting at this index. Okay, so will it I will be in a position to make an informed choice? Yes. For example, say suppose the money which I make in this case, let us say, is y, and the money if I get that I can make starting from index, this particular index is, let us say, y plus 1. Okay, so now I can choose like whether I should take this route or I should take this route, that is 3, the route 3, and add the 1 to that. Okay, so these are the two choices that I have. Okay, so that's why this case will work. So coming to my code, see, the code is very simple. One is the edge case here, as you can see in this case, that they have giving 1 as the you know starting number for the length. Okay, so if the number is 1, obviously there is no addition element at all. There is no need to solve anything. Simply return the element as such. Okay. Now come to the case when there are more than one elements. Okay. I will declare a cache array which is same as the size of the given array nums. Now cache of I is equal to the maximum amount of money robots can collect if starting at index I. Okay. I have already mentioned why this is important. Okay. Suppose I'm at index I. If I have the amounts that can be collected by starting at I plus 1 and I plus 2, I am in a position to make informed choice. As simple as that. Now I will do some pre-filling of the arrays. For example, the last element, okay, cache of n minus 1 should always be cache of n minus 1, that nums of n minus 1, because for the last element, if I am starting at the last element, for example 1, obviously there I have no other option but to fill it as it is. Okay, now coming to cache of n minus 2. See here, that's what I told you in the starting of the video itself. I showed you this example. If I have 3 comma 1, okay, let us say 1 comma 3. Yeah, let me quickly type here. I suppose I have 1 comma 3. Yeah, what will you select? Obviously 3 is going to be the answer, right? So for cache of n minus 2, that's why I'm saying take the max of the last two elements. That's what it is. Okay, take the max of the last element, that is max of n minus 1 and max of n minus 2. Okay, nums of n minus 1 and nums of n minus 2. Okay, take the max of them and store it in cache of n minus 2. Now for n minus 3 onwards, I will start a loop. Okay, it will go till 0. Okay, and it will be a reverse, as you can think of, right? For each cache of I, what I'm going to do, cache of I is equal to max of, now try to understand this factor. See, I will do the tracing, but still I want you to understand what is happening here. Okay, see, please try to understand. Suppose I am at cache of I. Okay, what could be the next probable option? I can do that. I can take cache of I plus 2, which is not, see, remember, cache of I has addition element I plus 1, and then it comes the element I plus 2. Okay, so I can take cache of I plus 2. Okay, and then add the nums of I. Okay, and to it. Okay, then I will get the answer. That is one way. Now what is the alternate way? The idea here is, if I do not select ith element, if I don't want to select ith element, then the other option will be to select the I plus 1 element. So I can check that also. If I go through the I plus 1 element, that is by not selecting the ith element, will I have a better answer compared to this. Okay, in each case, if I have that answer, I will take that. Okay, and in the last, I will be selecting, returning cache of 0. Let me quickly print and show you how this works. See, by don't go by my code, I will say the same thing. See, it's all about ideas, especially this kind of question. It's all about ideas. For example, see this. Come to the test case. Yeah, 3. See this case. Okay, for the last element, yeah, it is 3. Okay, if I started at this particular index, okay, what is the answer going to be? The answer is going to be 3 again. Why? See, suppose I'm starting at this index. I can select 1 or 3. Okay, so which will be better? Obviously, 3 will be better. I can select 3. Now come to this index. Okay, what are the various options I have? See, the first option is I can take this element as it is and take the cache of this element. Okay, so I can take this element 1 plus cache of the last element, which is 3. 1 plus 3 is 4. Okay, what are the other options? Cache of this element. What is the cache of this element? 3. Okay, so which is better? Okay, obviously this plus this is better. Okay, 1 plus cache of 3, which is 3. So 4 is a better option. Okay, now come to this case. See, it's very important. Now please pay attention. See, these are the cache values, by the way, and these are the nums, which is already given to us. I am at 2. Okay, what are the options I have? See, either I can take cache of the very next element as the answer, or I can take cache of the I plus 2th element as the answer and then add 2 to it. Okay, as similar. These are the two options. What are the options? See, either I can take 4 as the answer, or I can take 3 as the answer and add 2 to it. Okay, so what is 3 plus 2? Which is 5. Okay, and what is the other option? 4, which is better. 5 is better. So 5 is the answer. Okay, if you want to see for any other test case, for example, this, try to see here, 1 and 3. I hope you understood why they are there. Okay, now come to 9. Okay, I have the option 9. Okay, either I can take 9 and then add 1 to it. Okay, or I can take 3. So which is better option? Obviously take 9 and add 1 to it, it becomes 10. Okay, now come to this element 7. if I'm at 7, what are the options I have? Either I can take the cache of the next element. What is the cache of the next element? 10 as it is. Or I can take cache of the I plus 2th element, which is again 3, and add 7 to it, which is 10. In both cases, I'm getting 10. 10 is the option here. Okay. Now come to this case 2. What are the cases I have? I can take cache of the very next element, okay, which is 10. Okay, that's great. Or I can take cache of the I plus 2th element, which is 10, and add 2 to it. Okay, 10 plus 2 is 12, which is greater, so I can take 12. So 12 is going to be the answer in this case. Now come to the first, this particular case, with which we started actually. So why 3 and 1 are there as it is, you can understand that. Okay. Now come to the fact that for 2, what are the various options for 2, by the way? Just a second, let me scroll it properly. Yeah. So what are the options I have for 2? Either I can take the very next cache of the very next element, which is 3 as it is, okay, or I can take the cache of the I plus 2th element, which is 1, and add 2 to it, okay, which becomes 3. 3 is the case in both the options, so max of them will also be 3. Okay. Now come to this case 1. What I can do, either I can take the cache of the second element, okay, which is 3 in this case, or I can take the cache of the I plus 2th element, which is 3 again in this case, and add 1 to it, which becomes 4, which is greater. So that is the answer. So ultimately what we are doing is I am returning the cache of 0. Okay. So let me quickly run this and show you. I have already submitted this answer and it works. As you can see, this is working. Now, if you ask me about what, see, obviously, I hope this is very clear to you that the time complexity of this is going to be O of n, okay? Because as you can see, I'm using only single for loop, okay? The time complexity is going to be O of n, and the space complexity is also going to be O of n, okay? These things, I hope you are clear with this. If you have been following my video, I am sure that you will be now in a position to, at least for these small cases, easy cases, you will be in a position to guess the time and space complexities, okay? Now come to the fact that what are the optimizations possible. See, try to understand this fact. What I'm doing here is, see, for each cache of I, what are the things I required? See, nums of I you can ignore. Okay, that is anyway provided to us in the question itself. Nums of I you can ignore. But I need the cache of the next element, and I need the cache of the next to next element. Only two things I need. Okay. So, do I need a whole array to store all the values? The answer is no. See, ultimately, I'm returning cache of 0 as the answer, right? I do not need a whole array for it. Okay. So what I can do is, see, for each I need only the cache of the very next element and the next to next element. Okay, only two values I need. So instead of having a whole array, I can basically have as as only two variables. Okay, A and B, something like that. Okay, like we do in a Fibonacci series. Similarly, I just need two elements basically. Okay, as simple as that. If you can get it through that, it's very good, and yeah, you can proceed like that. Okay. So if you ask me what are the optimization that we can do, that is the optimization which you can do, something like that. I will give you this code and you can try that optimization. Okay. So basically what we'll do is, yeah, we will just command this out basically. Okay. And here, yeah, this will become A and this will become B. Remember, B is the n minus second element. So yeah, that's the one. So wherever and I plus 2 is mentioned, yeah, wherever I plus 1 is mentioned, okay, that will be replaced with B in this case. Okay. This will be replaced with B, and wherever I plus 2 is mentioned, that will be replaced with A. So this will be replaced with A now. And maybe you can store this in the answer as temp. Okay. Now we will have to transfer the values again. So what you can do is, see, try to understand the order here. What is happening? See, I have the element I. Okay. Then I have the element. Okay. Yeah. As you can see in this case, I will have the element B, and then I will have the element A. Okay. I hope you are getting the order. So what will now happen is they have to be transferred. The V's value should be transferred to A. That is, yeah, B. That's, yeah, A is equal to B and B is equal to temp. Okay, as simple as that. So as you can see, the last computed value is the temp, which is transferred to B. So what I will do is I will return B as the answer now. That is the basic. See, I've given you the whole idea. Maybe like I've missed something, but you can check that out and let me quickly run and show you. It may not be correct, but basically this is the idea. Because see, for every variable, we are needing only two values after that. Okay, I plus one, then I plus two value. So I hope this will work. But that is the basic idea. I may miss out something, but again, I am saying that could be a probable solution. Okay, as you can see, the test cases are getting cleared. I hope this will work in the long run also. I will quickly submit and let you know in the comment section if it works. But yeah, friend, that was the basic idea. As I mentioned, We did not have a whole array for it. As I have mentioned already, I need only the cache of I plus 1 and I plus 2 for the cache of I. Okay, so that is the basic idea. And if you want, okay, let me quickly and then show you as well. As you can see, the answer is getting accepted. Okay, it's taking just 42 milliseconds. But again, that varies based on the is the time at which you are submitting and something like that. All those like environment variables are also in picture there. But don't worry, I feel this is a better option compared to what we had earlier. We are using a whole array there, but yeah, the time complexity, that is the space complexity is changing, right? Here we have O of n as a space complexity, but if you can talk about this case, we are only using two variables, so it's a constant space complexity. It is not dependent on the value of n. Okay, so yeah, space complexity, I can say that it's O of constant, and time complexity O of n. So we reduce the space complexity from O of n to O of constant. So remember, these things are very important. Okay, in interview, if you get this kind of question, I am talking about coding interview and not the online assessment round. In coding interview, if you get this kind of questions, always they will expect you to optimize your code further. So you should be starting with a brute force approach and then optimizing further. I understand that the approach which I showed you initially is not a brute force approach. That was already optimized approach. But yeah, this particular optimization is again a good point to show them, and that we do not need O of n space complexity. We can just manage with O of constant space complexity as well. Okay, which also got O of 1. So I hope you understand this solution. This way you can do it. This was the case of dynamic programming with memoization, but I have again reduced it to like something like a one pass solution, as simple as that. So yeah, friends, that was all for today. If you have any better solutions, please do let me know. But try to understand this fact: I am not sorting. I am not doing anything. This code is often. I do not think you can solve it in a better way than this. Remember, if you want something like a log and complexity, then you should be getting the question in a sorted way already. That is a binary search. If you want to apply, you should always have the answer in sorted case already. But we are not having that. So definitely log and solution is not possible. And yeah, the minimum thing what I can think of is O of n only. Any other solution will be definitely greater than that. And if you ask the space complexity, I have already made it O of constant. There is no way to decrease it further, right? The idea here is, see, the space is not dependent on the value of n. Okay, that is the length of the nums. Okay, it is always 2, whatever be the length of the nums. So that's why it's called O of constant space complexity. So yeah, friend, that was all for today. I hope you find the solution interesting. And yeah, I really felt happy after solving this kind of questions and after giving you this optimization. If you like my efforts, if you want to subscribe to my channel, please go ahead and do that. We are solving constantly, and whenever I have a new idea to share, I am always making video and sharing it with you. This helps me continue my own streak. At the same time, it helps me improve my speaking skills and to connect with a lot of you. Okay, to get different ideas from all of you. Please do subscribe to my channel if you like my efforts. And yeah, we'll surely meet you tomorrow. Thanks a lot. See you tomorrow.